Okay, today is lesson 51, simplifying rational expressions with like denominators. And we have done some simplifying with rational expressions in the past, but now we're just going to take it one more step. So let's review some of the stuff we already know. First of all, identifying the excluded value. If we look at this example here, remember all we do with identifying the excluded value is we're trying to see what is going to make the denominator 0 because that makes it impossible. So that's the value we have to leave out. So we just take this denominator and set it to equal to 0 and solve because that will give us the value that the variable cannot be. So we're going to divide by 5 and m is 0. So the excluded value is m cannot equal 0. We have done this part before, so this should be a little bit of a review. But let's try another one. Okay, here I have 5m over m plus 1. All we need is that denominator. M plus 1 equals 0. I subtract 1. M equals negative 1. So m cannot be negative 1. That's our excluded value. Okay, another thing we've done a little bit of is simplifying rational expressions. So here, remember, we look at the numbers just like a fraction. So 8 over 12, we can simplify that. 4 goes into both of these. So if we divide 8 by 4, that gives us 2. If we divide 12 by 4, that gives us 3. So now, if we set up our new fraction, we've got 2 over 3. And then here we've got h squared over h to the first, which remember we subtract the exponents. So h2 minus h1 will just give us 1h, and this just becomes 2h over 3. That is simplifying. We've done this before. This should be a little bit of review as well, but let's keep working. This second example here is a little bit more complicated. So what we're going to do is look at the top and think what number can we take out of both 2m and 6, and that would be 2. Then if we divide 2m divided by 2, just leaves us with m. And 6 divided by 2 gives us 3. So now we have 2 times m over 3 minus m over 3. Well, we've talked about this before. We can now cross out m over 3 on both of these. So we're left with just 2. Let's try one more. We got kind of the same thing happening here. We got to think, what can we factor out? Well, 4 and 8, I can take a 4 out of both of those. And y squared and y, I can take a y out of both of those. So 4y squared, if I take out 4y, I'm just left with 1y. Plus 8y divided by 4y gives me 2. Then I have 4y times y plus 2 over y plus 2. So these both cancel out again, and this is just 4y. We are going to do one example here that just takes this one step further. So now notice, I didn't write this very well, let's fix this. Now notice that we have the same denominator here. So now it's just like adding and subtracting real fractions. So if I have b minus 2b, well, this is like having a 1 minus 2 gives me negative 1b over a cubed. We keep the denominator just like when you subtract fractions. This second example is a little bit more complicated because it has the negative exponents. But remember, we decided that it's easiest if you move the exponents first and then solve. So let's move that negative q to the negative 2 to the bottom. So we got q squared minus 7, and the p to the 1 is going to move up because it's negative over q squared. Well, now they have the same denominator, and we can subtract these. So 1p minus 7p is negative 6p over, remember the denominator stays the same, q squared. That is all there is to it. So today is mainly a review. Remember we talked about finding the excluded value where you just set the denominator equal to 0. Simplifying rational expressions where we subtract the exponents, try to factor out a number so that we can cross out a set of parentheses, things like that. And then the only new information is if you have the common denominators, we can add and subtract these variables as well now. So you should have everything you need. Go ahead and try out your work, and I will see you in class.